Welcome, guys. I'll be your online chemistry tutor. Alright, so today I'll be explaining the history of development of atoms. Alright, now basically we all know that, or we were taught that atoms were discovered by John Dalton. Alright, now the thing is that, well, it is correct to an extent, but then it is not totally correct. The history of development of atoms was actually started by two Greek philosophers. They were called Democritus and Leucippus. So these are the two Greek philosophers that actually discovered atom. Alright, but then they didn't discover the word atom. They called their own discovery atomos. Alright, so now this man here, John Dalton, he picked up their discovery, then he worked on it, he did a lot of things on it, he made postulations, and of course, so he did majority of the works on atom. So that was why the credit of discovery of atoms was given to John Dalton. So let's say the question asks you, the credit of discovery of atom was given to who? So the correct answer is John Dalton. All right. According to history, he was an English teacher. Yeah, he was an English second. He was a secondary school English teacher. Then he picked up their discovery. Then he named it atoms. Then he defined it. He defined atoms to be the smallest indivisible particle that can take part in a chemical reaction. Right. So that was what John Dalton said. So he made 5 postulates. Now let us go to the postulates of Dalton. Dalton's, it's called the Dalton's atomic theory. So, as I said, 5 postulates, right? So now, what are the 5 postulates of Dalton? The first one was atom is the smallest indivisible particle that can take part in a chemical reaction. So, alright, so now, what does this mean? Basically, it means that, let's say for example, this marker here. If you cut this marker into 2, you have 2 fragments. Then if you pick one of those 2 fragments, you cut it again, then you have a smaller fragment, you cut that one again, you cut that one again, and you continue cutting up to an extent such that you were able to get the tiniest part of this guy, such that it was not possible for you to cut it again. That is, it became indivisible in that case. So that was what Dalton called atom. That is, that part of this marker that you were not able to divide again, that is the atom of this marker. All right, so that was what John Dalton said about an atom. That was the first one. The second one was that when atoms combine, they do so in simple whole number ratio. When atoms are combining, they do so in simple whole number ratio. And of course, if you check the normal reactions that we write practically every day, you see that the ratio at which atoms are combining with one another, they are actually small. So for example, let's say the most common reaction that we have. Right, so we have hydrogen, 2H2 plus O2 to give you 2H2. Of course, what's the ratio of this? This is 2:1:2. That is the stoichiometric ratio. Basically, the number at the back of each of these atoms. So hydrogen, oxygen, water to give you water. So 2:1:2. Of course, this is a very, very small ratio, right? So that was what Dalton was saying concerning that. So now the third one was an atom of a particular element is alike in every aspect and differ from the atoms of all other elements. Let me take that again. An atom of a particular element is alike in all aspects, and the atom of that element though is now different, or it differs from the atom of another element. So now let me use this for example. So okay, let me write it first before I explain. All right. So this is what I was saying. Atoms of a particular element are alike in every aspect, and they differ from the atoms of all other elements. All right. That's basically what the third principle that we'll be talking about. Now let me explain this. This principle basically, this was what John Dalton was saying. This is an element, this is another element, right? This is green, this is element green, this is element red. Now, if you pick the atom of element green, if you check all the properties of atoms of element green, and then you compare it with the other atoms that comes together to form that big element, you will notice that the properties of all the atoms of that element, they are going to be alike in every aspect. They are going to be alike in what? In every aspect. Then if you now compare them to the atoms of this another element, they are not going to be alike. Did you get that? And also, of course, definitely means that if you compare the atoms of this element also, they are going to be alike in every aspect, right? But then they'll be different from the atoms of this element too. Do you get that? So that is that's what Dalton was saying here. Now, the next one, the number 4, the fourth atomic theory we'll be checking is atoms can neither be created nor destroyed. Alright, so atoms can neither be created nor destroyed. It means that you cannot create an atom from an existing atom, and you cannot destroy an atom, basically. So let me use red. All chemical reactions are as a result of combinations of atoms. Alright, so now this is what we have. So these are the 5 postulates of Dalton, and I explained everything. So let's go over everything from the beginning again, right? So now, the first one, atoms are the smallest indivisible particle that can take part in a chemical reaction. I explained that. So the next one, when atoms combine, they do so in simple whole number ratio, and I showed that with a reaction. H2 plus O2 to give you 2H2O. Now, the third one, atoms of a particular element are alike in every aspect, and they differ from the atoms of all other elements. So what does that mean? If you pick the atom of this guy, they'll be alike in every aspect, and they will be entirely different from the atom of this guy. Alright. So the fourth one, atoms can neither be created nor destroyed. That's quite straightforward. And the last one, all chemical reactions are as a result of the separation and combination of atoms. So those are the 5 Dalton's atomic theory. Now, the next thing we are going into is the verification of these guys. You know, it is one thing to actually say that, okay, this is, what's this? Now, it is another thing to be able to prove what you are saying to be correct, alright? So now, I am happy to tell you, that 4 out of the 5 Dalton's atomic theory were wrong, alright? Although some were not totally wrong, some were correct, but then to an extent, alright? While just 1 was correct, all true. Just 1 was correct, all true. So that was why I used another color to actually write this 5th one. This is the only Dalton's atomic theory that still stands till today, and I think forever actually. Now let us check what are the things that disproved this postulate. How are these postulates, how were they restricted, and what are the things that we noticed about them after their postulation. So let's pick the first one. Atoms are the smallest indivisible particle that can take part in a chemical reaction. Now, what disproved this postulate? It is the discovery of subatomic particles. So the discovery of subatomic particles. I'm still going to make another video, an entirely new video on this subatomic particle. It's a whole concept on its own in atomic structure, alright? Let us start from the basics first. The discovery of subatomic particles. What are subatomic particles? Subatomic particles, you have them to be 3, alright? Protons, neutrons, and what? Electrons. Protons, neutrons, and electrons. Now, he said atom is what? The smallest indivisible. But then, we are picking an element, alright? For example, let's pick sodium. So if you pick sodium, if you cut sodium to an extent, you will notice that you will get to a particular fragment where sodium will not be divisible any longer. But then, that is wrong. Because sodium atom itself, that smallest indivisible that you call the sodium atom, it can actually be divisible. If you take the concept of sodium atom, you will notice that inside that atom, you have what is called electrons that are revolving around. You have what is called the nucleus, inside which you have the protons and neutrons embedded, alright? Now you can actually divide these things. Yes, you can actually separate the electron from the protons from the neutrons. It is possible. But then, of course, it requires plastic conditions, right? But then, we can separate them, which means that an atom is actually not indivisible. An atom is what? An atom is divisible. So, this first postulate was wrong, practically. So, the second one, when atoms combine, they do so in simple whole number ratios. Now, what disproved this postulate? Now, when atoms combine, they do so in simple number ratio. There is a discovery that actually that goes against this postulate. And what's that? It is the discovery of organic chemistry. The discovery of organic chemistry. Now, in organic chemistry is a whole concept. We'll talk about organic chemistry in another video. Now, So when they combine, they do some simple number ratio, but then that is actually restricted to physical chemistry. In organic chemistry, you have atoms that are combining in hundreds, in thousands, if possible. So organic chemistry actually, you don't have them combining in simple, although to an extent you have them simple, you have them combining in simple number ratios. But then there are some aspects of organic chemistry that you have these things combining in large amounts, alright? So that is in organic chemistry. So the third one, atoms of a particular element are alike in every aspect, and they differ from the atoms of all other elements, alright? So that was what Dalton said. But then the postulate was also not correct. What disproved this postulate? It was what? The discovery of what is called isotopy. Isotopy is also another concept on its own, and we'll deal with it in another video also. So now, what is isotopy? Basically, isotopy is a concept that deals with isotopes. Basically, now what are isotopes? Isotopes are elements that have the same atomic number, but then they have the different mass numbers. Why do they have different mass numbers? Because of difference in their number of neutrons. Let's begin. Isotope is the concept of isotopes, basically. Concept that studies isotopes. So what are isotopes? Isotopes are elements that have the same atomic number, but they have different mass number. Now, atomic number, mass number, don't worry if you don't know what they are, we'll still talk about them. So now, why do they have different mass numbers? Because of difference in their number of neutrons. Now, basically that guy, that isotope, is telling you that this is an element, alright? Everything together is an element. This right here is an atom of the element. This right here is also an atom of the element. Now, it's not telling you that there are some elements that, if you compare two isotopes of that same element, you will notice that this atom and this atom, although they are from the same origin, that is from the same element, they have different neutron number. So they have different neutron number, although they are from the same element. Dalton said what? They are alike in every aspect. That is, the same proton number, the same electron number, the same neutron number, the same nucleus, the same everything basically. But then it is not totally correct. There are some elements that they have different nucleon, they have different neutron number. And of course, difference in neutron number is going to affect the mass number. And they will have the same atomic number, quite correct. Their proton number is always constant. Once an atom is from the same element, the proton number will be the same thing. Okay? So now, isotopy disproved this postulate. That is it. Now, the fourth one, atoms can neither be created nor destroyed. Well, to an extent, that is correct. Now, what disproves this postulate? It is what is called nuclear chemistry. Nuclear chemistry, or what? Radioactivity. Nuclear chemistry or radioactivity disproves this postulate. You see, in nuclear chemistry, we create atoms and we destroy atoms. Period. So atoms can be created and destroyed in nuclear chemistry. So which means that this postulate is also what? Is also restricted. It's also restricted. Alright, so now nuclear chemistry is also another concept. Alright, so those four postulates were disproved. Now, the last postulate that still stands is this guy here, right here. So what do we have? All chemical reactions are as a result of what? The separation and combination of atoms. So let me give an example now. So for example, if you have, let's say, a normal neutralization reaction. Alright, so now, here, what did Dalton say? He said what? All chemical reactions are as a result of the separation and combination of atoms. That is very correct. Like, that is 100% correct. This guy, of course, separates, it has to ionize to what? To Na plus what? OH minus. Alright? Now, this guy too, what's going to happen is it's also going to ionize to what? H plus what? Cl minus. So what is going to happen? They separated first. So what are they going to do? They are going to combine. So the positive goes to the negative and the negative goes to the positive. So Na takes Cl minus to form what? NaCl. And OH minus takes H plus to form what? To form H2. And that is on period. So that is it about the Dalton's atomic theory. Thank you very much. Have a wonderful evening and have a wonderful day. Thank you very much.